Okay. All right, so let's say we had taken this and we multiplied by 2 and we got 2c here. And to be honest, what we could have also done is write, well, the negative I guess I put over here. So when I multiplied by a negative, when I first flipped it, then I multiplied by the negative, so I put the negative on top. So let's say we had negative 2 over x squared plus 2c. Isn't that what it would be? Right? So I take 2 here, I take 2 here, so it'd be 2c, that'd be negative 2. Okay, now let's put in our 2, 4. Okay, so we have 4 equals negative 2 over 2 squared would be 4 plus 2c, right? Multiply that over there, we get 16 plus 8c equals negative 2, correct? Subtract 16, I get negative 18, so I get c equals negative 18 over 8, which is negative 9 over 4, right? So you get y equals negative 2 over x squared. Now let's go back to this. So what did I get here? I got negative 9 over 2, right? This time I got negative 9 over 4. So you're right, the c is different, but then look what happens. Now I take that and I put it back into the c, but I'm going to take that times 2. So negative 9 fourths times 2, right? Because I put negative 9 fourths back into that c. 2 times negative 9 fourths is what? Negative 9 halves. So I get, it makes sense. So you're exactly right. What will happen is if you multiply that negative times a c, if you multiply the 2 times a c and you call it 2c or negative c, you get a different c. But remember, that's never your final answer, is the c, right? You always take the c and plug it back in, and then once you put it back in, it'll simplify out to be the same thing, okay? So that's why it won't matter. But yes, you are exactly right. You will get a different c, but then when you plug it back in, everything will work out. So. Okay, and we can do one. I've got one on here that I want to do today. Okay, let's look at your homework first. So let's that's 7 for the separation of earth. I got another one we'll practice, and I know it's been a couple days here now, again. But which ones you want to look at for the homework? 27?
Yeah, and 30.
And 30. Okay, what's 27?
dy over dx equals 1 plus y squared.
Okay, dy over dx equals 1 plus y squared. Oh, hey. Okay. All right. So this looks exactly like one of those we talked about where it's got this plus, like we want to get the y, but the nice thing is just a 1, right? So how am I going to get this 1 plus y squared, or how am I going to get this y squared over here? You got to take the whole thing. Yeah, you can't just divide by the y squared. You can't subtract y squared. That doesn't work. All of our when we're going to divide, or whenever we're going to get the x's on one side, the y's on one side, it's got to be with multiplying by. We can't do any adding and subtracting. It's not going to work. Okay, it's not going to work. So we're going to divide that over here. And then, of course, we always multiply the x over here, the dx. Now, there's nothing there with it, but we can put a 1 there, right? So when we put our integral symbol like that, put a 1 right there. Now, what antiderivative is this? Arctangent.
Yes,
Arctangent. Arctangent. Arctangent equals x plus c. Now this is good, because this is good to talk about this one, because we haven't talked about solving an arc problem like this, an inverse tangent problems like this. So those would be good to discuss, but that's what it is. So yeah, we do need, page 333, right? We got to know our antiderivatives, not an ln. Remember, the only thing that's an ln is when you have 1 over x, or if you have 1 over y, or if you have 1 over 2y, right? If it's 1 over 2y, you could just pull the 1/2 out, and then it'd be 1 over y. That's an ln. Or you could have 1 over y plus 1. That's an ln, right? Or 1 over y, or if it's 3 over y minus 7, right? You could pull the 3 out, and then that's going to be ln y minus 7, right? There's another one that came up, somebody was asking me about. I think it's on another problem we have. What if you had 1 over 1 minus y? What would be the antiderivative of that? I know you think I'm tricking you. There's a little bit of a trick, but it's still ln, right? As long as it's y to the first, or x to the first, it's ln, okay? So it'd be ln of 1 minus y, and we put the brackets, we don't really have to worry about them in these problems. What are we missing though? Because of that number right there, right? Because of that number right there. Remember when you do, what's the antiderivative here? What's the antiderivative of cosine 2x? What's the antiderivative of cosine 2x? 1/2 sine 2x, right? That's the antiderivative because of that number multiplied there, right? Well, there's a -1 multiplied by that y right there. So you got to kick out a 1 over -1, right? Which is a -1. So you got, because think about it, what would be the derivative of ln? See, if you didn't have that, what's the derivative of ln 1 minus y? It'd be 1 over 1 minus y times the derivative inside. Well, the derivative inside is -1, right? So you got to remember that negative, right? You got to remember that negative. So be careful on that. Okay, that's going to come up. That's actually going to come up on a problem later today. Okay, so we got to be able to do these antiderivatives correctly. So anyway, back to this one. How do we solve this for y now? You do the tangent of both sides. So the x plus c would actually have to be inside the tangent right there. Now, did they give you an initial condition on this one? They did. Let's say they did. Let's say they gave you y of zero equals 1. So what would that look like now? 1 equals tangent of c. So what is c? What's the arctangent of 1? Pi fourths. Right? Where's tangent equal 1? There's a pi fourths. Because sine over cosine is the same, right? Root 2 over 2 and root 2 over 2. You need to know that. And so then you got to plug that back in. So now your answer would be y equals tangent of x plus pi fourths. And that would be it. Okay? So, you got to know, so again, to divide that, got to know that would be arctan. This would be x plus c. Then to solve an arctan, what you do to both sides, do the inverse. The inverse is tangent. So you do the tangent of both sides, it's that. You can stop there for the general solution. If they want the specific solution, you plug in your 0, plug in your 1, you get pi fourths. You get to use your calculators on this, right? So if you had to, you could do arctangent of 1, right, on your calculator. And there are other places where tangent is 1, right? That's just the first quadrant answer. But we'll just assume it's going to be the first quadrant, or whatever. If it's negative, we'd say negative pi fourths, maybe, or maybe you'd say 7 pi fourths, and that'd be okay too, or whatever. I mean, I'll give you some leeway on that when it comes to the treatments. Okay, what was the other one, Emily?
30.
What was that?
Y, ln.
So dy over dx equals y ln y. So both of those we're going to want to get over here, right? So we're going to want 1 over y ln y dy, and then over here we have just dx again, right? So what is this one? Now, depending how, like we could spend several days practicing a whole bunch of these, but it'd be just like going back and practicing antiderivatives again, right? Like we did for the gateway test. And we should be able to do those. This side, of course, easy. This is x plus c. What are you going to do here? What can I let u equal? Let u equal ln y. Because what's a du? 1 over y dy. Isn't that setting right there? Isn't that setting right there? U substitution, right? I mean, remember, the whole thing, all separation of variables does, all separation of variables does is say, here's a technique that you can do where you can separate the y's on one side, x's on one side, turn them into integrals, now do the antiderivative of both sides. Now, again, you're going to have a calculator. Now, one thing you got to make sure you do on the calculator, I'm not going to be here. So when you've got the calculator, right, when you type y, ln y, you got to put a times sign in there, right? If I give you if you've got I think this happens sometimes when you do a shell method. Like let's say your p value is x. I know I'm getting off topic here a minute, but let's say your p value is x minus 0. And let's say your h value is, I don't know, x minus 2 squared or something, I don't know. X minus 2 cubed, I don't know, whatever. Minus 0. Now when you put that into your integral, you go like this, x, and then you go x minus 2 cubed, like that, right? Dx, right? Everybody with me on that? So I set up my integral like this. If you type that in like that on your calculator, you may get some weird stuff, right? You've got to put, whenever you have that x or any letter in front of another letter or in front of parentheses, it's going to think that's a function you're trying to type in. You've got to put a times sign, right? It's going to think, if you type this in, it's going to think you're typing just some letters, y, l, n, right? You've got to put a times sign right here. I'm just saying, you should be able to do this, but since we're using calculators on the quiz bar, you could let the calculator do that antiderivative. Okay? Anyway, so that would be that. So that's all sitting right there. So this whole integral just becomes 1 over u du, and then that would be ln u, right? Well, what's u? Ln y. So this becomes ln of ln y. Like that. Now, how would you solve this? You'd start with this e right here, right? So e to the x plus c would equal what? Ln y, and then you have to do it again, right? So it'd be e raised to the x plus c equals y. Now you could leave it like that. Now remember how we said you could break this apart, right? So we could have this e, so this could be a big C e to the x, right? Like right here, we could break that into e to the x times e to the c, which would just be this. Then you could have e raised to that equals y. Did they give you initial condition on this one? Okay. And I don't look back and look. I don't want the answer to yeah, they have e to the a times e to the x. Or c. And again, you can use your calculator to help you solve that too, right? I mean, once you have this written down, you can tell the calculator to solve for y, right? I mean, I'm okay with that if you use the calculator for something else, but you know, sometimes the calculator can give you some weird things. But don't forget about this. Whenever you have a letter times some other stuff, put a times sign in there. Don't assume that when you don't have to is if you have, like if you have x times sign, you've got to put a times sign in there. If you got x times 2, well, even if you do x2, it's going to think you're doing a variable. So if you've got 2x, you don't have to. But if you've got x times something, you get it. Okay, which one you said? What was that one?
It is prime equals x over 1 plus 1.
Like that. So you're going to multiply this over there, right? And you're going to multiply this over there. So now you're going to do your integral. So you're going to have y plus 1/3 y cubed plus c, but we'll do that on the other side. This is 1/2 x squared plus c, right? And then this is where your question is, right? Because what are we supposed to do next? Solve for what? If you type this in your calculator and tell solve for y, I don't think it's going to do it. Maybe it'll give you something really weird. Sometimes it gives you something really weird, ugly thing. Sometimes you can't. It's okay. Now, the directions, like on the AP test, a lot of times they'll say, find the particular solution y equals f of x. What they're saying is you can get y equals, right? You can get y equals. Here, I don't think it said that, and sometimes you can't. We cannot get the y by itself. So on one like this, it'd be okay to just leave it. It'd be okay to just leave it. Did they give you initial condition on that? What was it? Now, and remember, this initial condition can be plugged in any time. You can plug it in now, or you can plug it in later. Now, one advantage of plugging in now, because what happens is, remember when we did slope fields with differential equations, and you had all these slope segments all over the place? And depending where your initial condition is, your curve might be up here, right? But if you have an initial condition down here, it might be down here, right? You had different branches, remember, of your differential equation, your solution. So what happens is when you get this general solution, this is for all the branches, right? And so when you put in, like you may go to solve this, now this one we can't, but you may go to solve this and you get a plus minus or something, right? And that's for the different branches. You're like, how do I know which one I have? Well, you know by this, right? The initial condition tells you, well, if you have y equals a negative square root, well, it can't be that one, right? Because you're getting a positive y. So it can't be the negative. So you can eliminate one of the branches by what your initial condition is, okay? But if you plug it in early, you might not see which one it is, right? So for example, let's see what happens on this one. So if I put a 2 here, 2 squared is 4 times a half is 2. If I put a 3 over here, I'd have 3 cubed is 27 times third is 9. 9 plus 3 is 12. So no problems. I only get one answer, so it's not an issue. But sometimes you might get a plus or minus here on your C, right? You might have a squared or something, and you might end up with a plus or minus, and then you're like, oh, God, which one do I use? Well, the one you use is the one that would give you that initial condition, not the other. And so that's what's important about that. So now we just take our 10 and put it up there.
It gives you some huge answer.
Yeah, sometimes the calculator will give you something that's just an awful looking thing. And I wouldn't expect you to type that out in the quiz, right? If you get something like this, where it's not readily apparent how you get the y by itself, you can leave it. But not this. I don't want you to do this. I mean, don't leave this here, right? Don't leave this here. You can do the tangent of both sides. That's easy, right? So, so you should do that. But something like that is awful. Okay? So we're kind of scratching the surface with that, but we'll practice one here. Let's spend a little time. I've got a few AP test ones here we could look at just for some practice. Trying to, you guys tell me if this looks familiar. I don't think we've done this one. This is 2013. Yeah, we don't have, it says set up but do not evaluate. So here you got a region. This was from 2013. And this is a no calculator one. Now notice they're already labeled F and G for you, so you can use F and G if you want here. So let's find this area, but this one I want you to actually work out. Now let's not work it out, because tomorrow we're going to be doing the calculator. Next week, have we done this one? Does this one look familiar?
That shape is.
We did A and B, and then we came back and did C and
Okay, all right, good enough. I thought it looked familiar, because I know we've done the F and G.
Yeah, we did it like last week.
I don't think we worked it out, but okay, I think you're right. Okay, this one I'm pretty sure we have. Here it is. Okay, go ahead and set those. Or have we done this one? I don't think so. Okay, first one says, so they give you, now this is a calculator. So you can go ahead and use your calculator here. Okay, so it gives you the two graphs and find the area. Then you got a base of a solid where the cross sections are squares, and then you got this horizontal line. So let's go ahead and set up those integrals and actually type in your answer for part A, and get that answer.
All right, so people watching can freeze their video at this point. So there's the answer to part A, horizontal strips, vertical strips. Part B has to be vertical strips. Part C, one way to set it up, or what we say the other way to set it up? 0 to K, 5 minus y minus e to the y equals the integral from K to, and that was 5 minus y minus e to the y. So that would work also. All right. So one more thing, and then I've got a worksheet here with some problems. Let's look at this one. This is from 2010. This is a no calculator one, but mostly it's solving, but we can solve this one. But here we go, very, very similar scenario. Let's don't worry about, well, go ahead and do it. Let's do part A. Let's find the area. I did. You guys are awful right now. Jeez. Okay. And I can't start the recording without getting rid of my work here. Okay. Oh no, it is going. I think. Okay, now it's going. All right. Well, you guys keep working. And so for those viewing at home, write up my answer for part A.
Wait, so what do you do that? 54 minus 4, 3 plus. It's 90. Next. 90. Did you want to freeze the screen?
No. So part B, here we go. Dishwasher and shell. Let's do both. freeze it. Look. Actually, erase it.
I wrote 7 minus y, but then I wrote 6 minus 2x instead of the 1 4
Questions?
You don't go to the line that it's revolving around for the shell, you just go to the.
Remember how we said the strips fill the space? So on shell, so you're revolving like this, right? Strips fill the space from 0 to 6.
And that's how it takes care of that empty space, because that would be empty space when that revolves. That would not be part of the volume. And so that's how you eliminate that. And that's how the way washer eliminates it, by doing the big R minus the little r, right? That's how that eliminates the empty space. Shell eliminates the empty space by only going from there to there. That's right. So that's why you only go 0 to 6. So H would be right minus left. H is always the strip that's parallel to the axis of revolution. So this is H right here. So 1/4 y squared minus 0. And then P remembers that distance from the center to the strip. So that's 7 minus y. Remember, P is always like 7 minus y or x minus 2 or 2 minus x or whatever. So that's your shell. Okay. So be able to do both on the quiz. If you want to do both to test them, that's fine. But you don't have to do both unless it says to do both. I mean, it could. And I think on the review worksheet, I've got one where I tell you to do it both ways. And just for practice, I think I've got one like that. Just for practice. Or no, I think I have one where I tell you to do horizontal strips. That's good. Okay, now let's just talk about C real quick, and I want to let you know some work time. So region R is the base of a solid. For each, oops, still frozen. For each cross section taken perpendicular to the y-axis. So now we've got our strips are here, right? The cross section is a rectangle, and again, what I say this was 2010. This caused a lot of consternation because they had typically done semicircles, squares, whatever. But this made you think a little bit. The cross-section perpendicular y-axis is a rectangle whose height is 3 times the length of its base in region R. Well, what's its base in region R? This green strip right here. So the base of this rectangle is 1/4 y squared minus 0, right? So coming up off of the page here are rectangles, right? Can you picture that, right? Coming up off of there is a rectangle. Well, what's the area of that rectangle? Base this times what? Its height, which is 3 times that, right? So won't it just be 3/4 y squared, right? So remember, what do you put in the integral? What goes in the integral is the area of the slice, right? So it's the area of a rectangle. Well, it'd be the base of the rectangle, which would be 1/4 y squared, times its height, which they just told you is 3 times that thing. Does that make sense? It's just 3 times whatever its base is that's in the region. So whatever this strip is, call it B, the height then of your rectangle is 3 times that, 3B. So it's just 3/4 that. And then it's going to go from 0 to 6. That's it. That's it, right? So it should be able to think our way through that. It's all, because all you can really know is the strip, right? That's all you can really know on these base of a solid. So whatever slice shape they give you, somehow you've got to be able to write the area of that using that strip information, right? I mean, it's got to involve that strip. So our semicircles, the strip is the diameter. Our squares, the strip is a side. For equilateral triangles, the strip is one side of that. And so you've got to be able to do that every single time. All right. So that's that. As far as the work or rope in a bucket or spring, I've got some of that on here. If you want to do those first, I've got another one on here with the separating variables, the separable difference equations on here, but then there's an arc length one on here we talked about, so if you want to do that one first, or whatever to practice that, you can. I've got the answer sheet up here all worked out, so if you want to take a picture of that before you leave, so if you don't get them finished here today, you can take that with you. And then tomorrow, let me give you this. So tomorrow's going to be the quiz. I don't think it'll take you the whole time, but you can have the whole time. Our last big sample packet is this one here, because we're going to be starting our finals next week. I'm guessing Wednesday. Right now, my thought is Wednesday and Friday. Is there anything big going on next week you know of on those days? Thursday's Omaha North Track meet, I know, and I'm not sure about 10 or something about phase, you can't miss, but so I think golf, there's one of those days that we have this year. Yeah, I think he said he's got golf next week, Tuesday and Friday, so I don't know if he might miss Friday, so we have to make that up. But anyway, so all I'm saying on this packet is get started. We want to use the next 2 days next week to kind of get through the multiple choice, because those are the parts we're kind of getting ready for. I will have some other problems we'll be working on as we go along, but so tomorrow, after you get done, just work on the multiple choice a little bit, but quite honestly, you probably don't have to work over the weekend on it any. I think we can be working on it next week some, so I wouldn't get too carried away with it, but I think when you get done, if you get done with the quiz early, then this is what I want you to work on, and you can work in that sample packet. Okay? All right, the answer sheet is setting up there on the table up there. I want to check as you go.